All right, hey folks, we're back again. Slide 10 is going to be the area of a regular octagon given a radius here. So anyways, the purpose of these problems, they meant to make it kind of hard for you, but we, make it hard for you so you can make connections and realize there's got to be a way we can get this area of this particular regular polygon if we knew a few things. And specifically, it's not the radius we care about. We're using the radius to get a side length and this altitude here, the altitude of these isosceles triangles. We know one of those altitudes we'd be able to get the area of any of those triangles. Anyways, that's enough to get us eventually to the area of the octagon. Okay, so what that altitude's called is something called an apothem. Apothem. There's a word for everything, isn't there? So we'll talk about that a little bit later. Hey, my last video here, slide 9, it cut off before I was done. It did. I just went and rewatched the video. I was like, why is it only 9 minutes? It felt like it was 12 minutes, and I know the difference. So here, just make sure that you got the right answers here or follow the whole thing. So again, the area of the hexagon is 6 times as large as the area of the triangles that we found. So we take 25 root 3 centimeters cubed, multiplied by 6, we get 150 root 3 cubic centimeters would be an exact answer. But if they're expecting you to round it to the nearest 0.1, so about 259.8 cubic centimeters here. Also, what I also did in the video, got cut off. I know it was hard. Perimeter. Okay, perimeter. Sum of the lengths of the sides of that regular hexagon. And of course, you got 6 sides if we're talking hexagon. If it's regular, all those sides are going to be the same as one another because a regular polygon is equal angular and equilateral, right? So it's equilateral. These would all be the same lengths. And what did we find? Well, we found that the side length was 10. So 6 times 10, 60 centimeters. P equals N times by S. So that moves us on to slide 10. So hopefully you got all this. Sorry that my video cut off, but this here. All right, let's do this one last time. Get the area of a regular polygon here. In this case, it's going to be an octagon. Number of sides, going to be 8. And number of angles, we'll figure it all out here. Okay, let's do it over here. Let's get this one here. Because remember, the goal of this is, what I eventually want to get to is, this is my side length right here. Okay, I got a side length right here. I got to figure out what my altitude is. I know my radius is 10. Get out of my way. Radius here is, it's not actually drawn perfectly here. Okay, radius is 10. Okay, side length here. Okay, the area. Okay, so area, just to point out things here, it's going to get us closer to a formula. Area of this triangle here, that's part of the regular octagon, is 1/2. Base is S. Okay, base is S, believe it or not, because each side length, right, going to be the base of one isosceles triangle. Right, isosceles triangle. We got this isosceles triangle here, and then 1/2 base times by height. And that is, that little height thing there, apothem. Apothem, that stands for apothem. A equals apothem. Yeah, it's kind of like, it's the altitude from the center to one of the sides, right? Meaning the length of the perpendicular segment from the center of this regular polygon to one of its sides. A equals apothem. So that's the area of one triangle. So the area of the octagon, okay, well, that's going to be 8 times that. Right, 8 times that 1/2 length of his side, size of the apothem. So as long as we can figure this out, and we can, using trig, we can figure out the area of the octagon because we could figure out using trig getting the length of the apothem. Figure out using trig, figuring out what 1/2 S equals. Okay, should we do that now? I think we should. And that gets us closer here, okay? Area of a regular polygon. Let me just put the formula here because we're getting close. Area of a regular polygon, okay? Where that 8 came from, that's the number of sides, okay? That's the number of sides. It's actually this. This is the formula. 1/2 height of the apothem, base is represented as S. 1/2 A times by S times by N. There we go. Area of a regular polygon formula equals 1/2 A times S times N. Side length, though, times by number of sides, well, that would actually just be the perimeter. Perimeter equals number of sides times side length. So anyways, this is it. This will appear in some geometry textbooks here. 1/2 AP. 1/2 AP. Anyways, am I going to cover that with you this weekend? Probably not. I don't know. 1/2 AP. And I think the P should be lowercase. perimeter should be a lowercase thing because that's a one dimension, right? Added it all up together. So it's not a two-dimensional thing, so it shouldn't be capitalized. Anyways, there we go. There's your formula for area of a regular polygon. Do with it what you will. But hey, let's go ahead and solve this problem. Let's go ahead and do it. Okay, so what do we know about the interior angle of a regular octagon? Well, we know it's 135 degrees. I'm going to do that kind of quickly, double check that in our heads. N minus 2, so 8 is the number of sides. Minus 2, that's 6. Times by the amount of triangles you can create from one diagonal, and that would be 6 triangles, so that's 180 degrees total. 6 times 180 would be what? 1080 divided by 8. Boom, that's where you get the 135. Okay, so I'm hoping you all did that. I'm hoping you all know how to do that. Okay, remember, my 135 degrees divided by 2, well, that equals 60. Wait, did I do this wrong in class earlier? I did. It's 67. Yes, what the heck is wrong with me? 67.5 degrees. Mr. Fortin, simple mental math there. I think I was writing 62.5 degrees when I very quickly try to talk about this in class, in the end of class here. So I'm going to use 67.5 degrees. Oh, why am I printing it out in black and white? I don't want to do that. Okay, let me zoom in. Oops. I don't want to print it. There we go. That's what I'm talking about here. All right, so here we get surgical with it, right? We get our surgeon's glove in. We try to get it here, okay? So here, half this, remember, the radius is going to bisect that interior angle. It is, right? Because remember, these are all like congruent isosceles triangles. So through CPCTC, that would equal that, okay? So anyways, 67.5, that's half of 165. And I made that mistake in class. I know I did. We'll see here. Let's see if it trips you up. And if it does, whatever, you're going to work through it. It's all about getting back up on the bicycle when you fall down, okay? Here. All right, here we go. Let's do it. Let's freaking use trig. Okay, use trig, and let's do it. Let's solve this piece here. There we go here. All right, we got here. This is 67.5 degrees. Here's my reference angle. Remember, this is a right triangle. So what am I going to use? So I can use sine, sure. Sine of 67.5 degrees. What do we know? That's going to be in the ratio of the apothem to the 10 centimeters. So that is what I want to do first. Multiply both sides by 10. Hey, I can just do that. Do that on my calculator real quick here. Sine is 67.5 degrees. Take the sine of that. There we go. Oh, that should be pretty big. 67.5 is a pretty big angle. Divided by 10. All right, about 9.23. A is about 9.24, let's say. Sure. Well, 9.239 I might do. Okay, you generally want to have more digits earlier on because then later you can round. You don't want to round too early because then you're getting off by like a decent amount there. Anyways, I think that's fine. Just to throw a bunch of digits there. You know, it's getting pretty close. It's close enough to 9.239. All right, there's the apothem. Now we're gonna get a side length here. I can use trig again. Check it out here because if this is my reference angle, this is the opposite side. That would be the length of the apothem. This is the hypotenuse here. Okay, and 1/2 s, that would be the adjacent side to that given 67.5 degree reference angle, which we deduced, right, using the measure of an interior angle of a regular polygon formula that you reviewed yesterday in class here, okay? So I want cosine, because toa, cosine of a given reference angle is its adjacent to hypotenuse ratio. So I'm going to do 67.5 degrees equals, and here, right, math gets a little bit funky here. I'm going to put a fraction in the numerator. Oh, gosh. Okay, that's 1/2 s. That's my adjacent side length here. Remember, I want to solve for all of s here. And that's over 10. Okay? I can isolate 1/2 s, and then I can multiply by 2 afterwards. That's what I'm going to do here. So I'm going to do this. I'm going to do cosine of 67.5 degrees. What's the sign? I hit the wrong button. 67.5. I'm going to hit cosine. I get 0.3826. That's the cosine. That makes sense that the adjacent side length to the hypotenuse ratio is going to be a lot smaller than the opposite side to the adjacent. Because 67.5, again, is a pretty freaking big angle right there. Big acute angle, at least. Okay? So I got this. I'm going to multiply it by 10 so I can isolate, okay? I can isolate what? 3.8268 equals 1/2 of s. Remember, that adjacent side here is 1/2 of the ultimate side length. of this regular octagon right here, okay? What do I do to figure out what the side length is of that regular octagon then? Well, I have one half of it, and that's 3.82268. So you know what? I just multiply both sides by 2. I double it. I got half. I want to get the whole. Well, I double the half to get to the whole. So I can take this, what's in my calculator. I always leave it in my calculator. That's it. It gives me a more precise answer. I'm going to multiply it by 2, and there it is, a good approximation of how long that side would be of this regular octagon that's given to us. We know it's regular because it's given to us. So 7.65. I'll just use 7.65. I don't think that's probably be fine here. 3 is kind of low. I'll stick with 4 there. Just to be careful. Better be safe than sorry. Okay? All right, I got a side length. Okay, I got the apothem. Hey, I got a formula you could possibly develop, or you can just kind of reason through it here. I'll just reason through it the way that you're probably reasoning through it, okay? Here we go. Let's do this. Area of a triangle, this triangle here. Okay, this is what I'm talking about here. Okay, area of the isosceles. So I know what you're just thinking. It's like, oh, I got a right triangle right here, too. No, I'm not talking about that one. I want to talk about if I draw on 2 radii of this isosceles triangle. Isosceles triangle here. Isosceles triangle here. Isosceles because all radii are congruent in a circle. So all radii would be congruent in a regular polygon because it can be inscribed in a circle with this particular radius. Okay, so I got 1, 2, 3, 4, 5, 6, 7, 8. How about that? An octagon has 8 triangles. Isosceles triangles get formed by connecting the center to each vertex. Okay, area of an isosceles triangle, let's do it. 1/2, base is S, but we figured out S. It's 7.654, okay? Centimeters, of course, here. Okay, base times by height, that's the apothem. We solve for that up here. That's 9.239. Okay, let's get it. Mathematically, times by 9.239. Okay, remember, 1/2 base times height, so don't forget to divide by 2 at the end there. About 35.3. 35.36 cubic centimeters. Sorry, square centimeters. My bad. Because again, this is a 2-dimensional calculation, right? Area of this is in 2 dimensions, left, right, up, down, so not in 3 dimensions, doesn't have depth. So we do centimeters squared, right? That's what fills in here, right? These are square units here. Okay, that's the area of the triangle. So the area of the octagon, area of the regular octagon, well, that's just going to equal 6 times whatever that area of the isosceles triangle is. Okay, so that just simply equals 6 times by 35.36 square centimeters. Okay, so I'm going to go ahead and multiply this by 6, and I get about 212.1. Ooh, I'm pretty close to 212.2, so hopefully I didn't get that wrong. Okay, about 212.2 square centimeters. Okay, there's my area. Let's cross that out. We did area there. This is my area. There's my answer right there. Okay, what about perimeter? Okay, perimeter. Let's get that. Perimeter's right here. Okay, area we got right there. Okay, perimeter. Well, that's the easy part here. We're going to take that perimeter. I should do it lowercase too. It should be lowercase, not uppercase. Perimeter equals number of sides times by the length of each side here. Okay, number of sides of an octagon is 8. Right? It's perimeter of a regular octagon, regular polygon. It's the number of sides of that regular polygon times by whatever the side length is of the regular polygon. Remember, regular polygons, equiangular and equilateral. So we got 8 times by the side length is like 7.654. Okay, and that's going to be about 61.2 centimeters. And that's what I got. Hooray, we got another one down. I might film one more video going through slide 11. Okay, perhaps here, slide 11. Thanks for watching. Message me if you have any questions. Or watch the next video.